What is the fundamental difference between a traditional computer program and a machine learning approach? According to source material, option A, machine learning is only used for complex tasks like image recognition, while traditional programming is for simpler tasks like e-commerce. Option B, machine learning programs are capable of writing their own code from scratch, while traditional programs must be written by a human. Option C, traditional programs follow explicitly coded rules, whereas machine learning algorithms learn patterns directly from data. And option D, traditional programming are designed to be 100% accurate, whereas machine learning models are designed to be probabilistic and less precise. Option C, traditional programs follow explicitly coded rules, whereas machine learning algorithms learn pattern directly from data. So because like traditional programming will have rigid sets of rules. Okay, with machine learning, it's going to learn from the experience by when we present the data with it. Okay, and next, in the context of the wake word example, Alexa, how is the programming taught to recognize the word? Option A, by giving the program a dictionary of English words and a grammar engine to parse incoming sentences. Option B, by having the program listen to a live audio feed and receive real-time feedback from a human supervisor. And option C, by designing a system with explicit hard-coded rules about the frequency and amplitude of the sound wave. And option D, by providing the program with large dataset of audio snippets that are labeled as either containing the wake word or not. So for recognizing the third word from the program, we have to by providing the program with large data of audio snippets. So if you want to recognize the particular wake word, it has to train with large amount of data of audio snippets. So not only audio snippets, it has to be labeled, and that particular audio snippets may contain wake word or not. So option B. This describes the core idea of supervised learning presented in the text, where a model learns from the huge data set. So we need a training data set. We have a test data set. So the model will be trained from the training data, and we are going to test the model from test data. Next question. What is the role of models parameters in machine learning process described in the text? Option A, there are fixed values that defines the model's architecture and cannot be changed during training. Option B, there are adjustable knobs within the model that are tuned during training to improve performance. Option C, so there are raw input data such as images or audio files that the model processes. And option D, there are finer predictions or classification that the model outputs. So obviously adjusting the knobs within the model that are tuned during the training to improve performance. That's right. So the analogy of knobs that can be turned, stating that parameters are determined by training process to improve the performance of a program. And next question. Which of the following is not one of the four key components of a machine learning problem as outlined in the document? Option A objective function to quantify the model's performance. Option B, the specific hardware used for computation. Option C, a model of how to transform the data. Option D, the data from which the system learns. The specific hardware used for computation. While hardware is necessary to run the process, and conceptual components of problem itself, data, model, objective function, and algorithm. In supervised learning terminology, what are the features of a data point? Option A, the entire collection of examples that constitutes the training data set. Option B, the special attribute that the model is trying to predict for each example. Option C, the set of attributes or numerical representation that are used as input to make a prediction. Option D, the number of examples available in the dataset, also known as dataset size. So option C, the set of attributes or numerical representation that are used as inputs to make the decision. Depending upon the input only, we can able to make the predictions. The example consists of a set of attributes called features which form the basics of model predictions. What is the primary purpose of an objective function, also known as loss function in machine learning? Option A, to provide a formal mathematical score of how well a model is performing. Option B, to select the most suitable type of model for a given example. Option C, to pre-process the raw data into a numerical format suitable for the model. Option D, to systematically adjust the model's performance to improve its score. Loss function, to provide a formal mathematical score of how well a model is performing. The text warns of garbage in, garbage out. What does this principle imply about machine learning? Option A, sophisticated model can overcome flaws and bias present in the training data. Option B, it is more important to have a large quantity of data than high quality data. Option C, the performance and fairness of a model are heavily depend upon the quantity of its training data. Option D, models are designed to automatically detect and discard low quality data during training. Option C, the performance and fairness of a model are heavily dependent on the quality of its training data. This correctly captures the idea that if the data is flawed, garbage in, the model prediction will also be flawed, garbage out. Why is it crucial to evaluate a model on test dataset that was not used during training? Option A, to verify that the training data is clean and does not contain any errors. Option B, to check if the model has simply memorized the training example or if it can generalize to new data. Option C, to reduce the overall computation time required for the training process. Option D, to perform the final adjustments to the model's parameters for optimal performance. To check if the model has simply memorized the training example or if it can generalize to new data. Option B. What is the overfitting in the context of machine learning? Option A, when the optimization algorithm fails to find the best possible parameter for the model. Option B, when a model is too simple to capture the underlying trend in the data. Option C, when a model performs exceptionally well on training data but poorly on unseen test data. Option D, when the training data is too small to build a meaningful models. Overfitting. When the model performs exceptionally well on training data but poorly on unseen test data. What is the primary function of a optimization algorithm like gradient descent? Option A, to systematically search for and update the model's parameter to minimize the loss. Option B, to define the structure of model and its family of functions. Option C, to split the dataset into appropriate training and test sets. Option D, to calculate the performance score of model using the objective function. To systematically search for and update the model's parameter to minimize the loss. So that's all for this video. So I will catch you in another video.